Hello, everyone, and welcome to my talk today, The Hype and Hope of Microservices. So in this talk today, what I hope to do is give you a little bit of the big picture about microservices. First off, what are they and why are they important? What problem is it that microservices are solving? And then I'm going to talk about some of the day-to-day pains that you encounter as you go in to deploy maybe your first microservice architecture. Because even though microservices are in fact a solution to many real problems, nonetheless, they're not the simplest technology to deploy successfully at scale. And then finally, in the end, I'm going to talk a little bit about where microservices are going, what sorts of technologies exist out there to help make companies more successful when they attempt to go down the microservice architecture, and how that might change over time. And finally, I'm going to try to do all of this in 30 minutes. Which is going to be a bit of a challenge because in this pandemic era, I've gotten used to giving 2-hour-long talks. Feel free to cut me off if I start running over. All right, hype. Where do microservices come from? Well, if you're not doing a microservice architecture, you're doing a so-called monolithic architecture. And monolithic architectures, they bundle all of the functionality required by an application into a single unit that exists together. It's packaged together, it's deployed together, it's run in production together. It is the monolith. It's the Ruby on Rails app. We've all had these monoliths, we've all built them, we've all dealt with them. This was the way you used to build all applications. All applications were monoliths. And it's only really the edge of the application, the outside world, that interacts with the service directly. And then every other part of the application is just a bit of code. And so you have code calling other code and so forth. And there definitely are advantages to building a monolith. And one is it's just lower overhead. And that's because in a monolithic application, one part of the code simply directly calls another part of the code. There's nothing in between them. It's just ordinary code, all living together, possibly even in the same repository. So that reduces overhead and helps you move faster when it comes time to developing applications. However, we have learned from trial and error from many monoliths over probably 2 or 3 decades now that this style of architecture is fraught with serious drawbacks. And one of them is maintenance. So we go in and we need to change some part of our application like search, and we need to add new features or change the way it works a little bit. And then unfortunately, we have to go into all the other pieces of our application that are using that, and we have to change them at the same time. And of course, this is happening concurrently in parallel by all the developers who are working on the monolith. So if you've got 50 developers all changing one part of the application, they're all updating their part, but then they're updating all the other parts of the application at the same time. And that creates a maintenance nightmare because it could very well be that most of the other parts of the application, they don't need the new functionality. They don't really need to be updated right now. And having to update them is going to slow us down. It's going to add complication. It's going to extend the amount of time in which we're all sort of concurrently editing all of these different files and trying to make sense of them and doing pull requests and merging conflicts and all of that. Creates maintenance hell. And not just maintenance, by the way, but also when it comes time to deployment, the monolithic nature of this application really gets in our way. So we change the search component, and then suddenly we've got to deploy all of the other components, even if they weren't ready to be deployed, and even if other developers were working on other features inside those applications that are maybe not quite ready for prime time. And of course, we solve that problem with pull requests and by making sure that we delay merging pull requests, but that creates other sorts of problems such as conflicts and this and that, cherry picking that leads to 2-week freezes, feature freezes on a stable branch while everyone does work in the dev branch. It leads to lots of overhead. There are ways you work around the pain of deploying this thing together as a single unit, but it is quite painful. And then another reality of the monolithic architecture is that different parts of our application, they don't all need the same thing. Search may need Elasticsearch. And our transactional email may need Amazon Simple Email Service. In some parts of our application, like fraud, they may be extremely CPU or GPU intensive. Other parts of our application might require gobs of memory. And by bundling all of these things together, which all have different requirements, they all need different things, and they all need different number of nodes to run on, by bundling them all together into a single unit and deploying that uniformly, we're creating a situation in which the entire monolith needs everything, and it needs the maximum amount of RAM needed by any part of the application, as well as the maximum amount of CPU and the maximum number of nodes required by the application as a whole. And of course, that leads to massive inefficiencies. Another, I think, less appreciated drawback to the monolithic architecture is that it violates something programmers value, which is encapsulation. And the easiest way to think about this is that, let's say we have a business rule. Our business says that anytime a user goes in and changes their user profile, they update their name or their address or whatever it is, then we want the user to receive an email notifying them of that change. Well, that's not so easy to do in a monolith, and the reason why it's not so easy to do in a monolith is because all parts of our application have direct access to the database that stores all user records, and no one can really stop you from going in and running a SQL update query to go ahead and change that information, and do so in a way that does not result in that user getting the email that the business specified. As a result, enforcing business logic in a uniform way across a gigantic monolith application becomes extremely difficult. And you have to rely on convention and discipline and skill and training and other sorts of methods that work, but they're not very reliable, they're not very scalable. And then another serious drawback for the monolithic architecture is failure scenarios. So there's two types of failure scenarios. One occurs when we've got a bug in some component. And these types of bugs, they can be pretty serious. And when they affect one part of it, they really affect the whole. An example is, let's say search has a memory leak. Well, then every component of our application has a memory leak because it's bundled together in a single monolith. So, and not just search, by the way, but any component here that has any sort of a problem would be fatal to the entire unit, the entire monolith. So it's not very resilient. It doesn't give us a way to deal with errors in a resilient way. In summary, monoliths, really, they are anti-lean. And I mean that in the sense of lean manufacturing, lean software development, due to the fact that they couple together all these different pieces of the application into the same unit for packaging and deployment and operations and all of that. They dramatically increase the amount of sort of work in progress, the amount of stuff, value developers have created that's just sitting around in pull requests and not being used by the end user of the software application. They also lead to increase in process variation. So in any sort of monolithic architecture, there will exist points that are catastrophic, and they result in significant downtime and other types of situations, or you might not be able to ship a new feature for 4 weeks because something happened. And all that comes from the process variation that stems from the architectural coupling. And if you want to know the impact that these things have on the business, well, it's straight up from lean software development. Whenever you have increase in work in progress, as well as an increase in process variation, then it leads to an inability to responsibly deliver value. So quickly, on a timely and reliable schedule, deliver value to the users of the application. And as well as, okay, there's a side effect that's not so obvious. You can't ship stuff quickly, but also you can't learn quickly. And if you can't learn quickly and someone else can, well, they're going to learn a whole lot faster than you, and they're going to out execute. And so technology, your lack of sort of best practice technology implementation for your architecture can actually lead to you losing in a head-to-head competition. And that's why the tech companies, by the way, like Amazon and Netflix and so forth, that's why they're all extremely dangerous. They are dangerous because they can put other kinds of companies out of business. They are so good. They are so agile. They're so lean. They can put other people who don't know what they're doing out of business. And that's why it's important to, at least in competitive industries, to take these things very seriously. Microservices, they came along and introduced a new type of architecture to solve all of these problems. And a microservice architecture, instead of having one that gigantic monolith that packages and bundles everything together, it divides the application into lots of different pieces. Each piece is called a microservice. And each piece is packaged, it's developed, it's maintained, it's packaged, it's deployed, it's upgraded, it's versioned independently of all the other microservices out there. You can really think of microservices adding lubrication. You know, it breaks, it fractures up that big monolith into pieces and adds lots of oil into all the pieces and allows them to flow together in a fluid fashion. And through this architecture, you can solve all of the problems of the monolithic architecture, all of them, 100% of them. So first off, maintenance becomes way easier. You change subscriptions, you add something to subscriptions that's needed by purchases, and you only need to update purchases. You know, that's it. Or actually, you don't even need to update it. You could just issue a new version of subscriptions, and then later you can go in, or the purchases team can go in and use the new functionality as necessary. None of the other stuff needs to be updated. So it radically simplifies maintenance. In addition, it simplifies deployment. When we update shipping, we just have to redeploy shipping. We don't have to touch any of the other stuff. So way less risky. We can do that very quickly, very easily, without a lot of risk. It simplifies, it makes more precise and more efficient infrastructure, because every different one of these microservices can have different dependencies, and they can require different amounts of CPU, different RAM, different numbers of node, different pieces of infrastructure. Some require Postgres, some require Elasticsearch. We're free to make every microservice only require and have access to the things that it needs to do its job, which results in efficiency and, of course, encapsulation. And then finally, even though microservice architecture, it doesn't mandate encapsulation, it's much easier to enforce encapsulation with a microservice architecture. So for example, we can make sure that no one can touch user account details, the database that the user account details are stored in, unless they go through the user account service. We can mandate that. That can be actually enforced at the level of infrastructure. So if any of these other microservices wants to change the user details, they have to go through user accounts microservice. And as a result, we can put any sort of business logic in there, such as sending that email notifying the user that their account details have changed in some way. Microservices, what they do really is they are pro-lean. They decouple our architecture. They just fracture that big old monolith into all these different independent pieces. And as a result, they radically decrease work in progress, and they result in minimization of process variation. And as a practical matter, what that means for your business is you can responsively deliver value to users, and you can learn from feedback. And the big companies that have these microservices architecture and have done them well, they can ship new features in an hour. And if you have a big monolith, you know that's not possible. That's not even remotely possible. You're going to have code freeze and all the other sorts of things that happen when you have gobs of people all working in the same gigantic monolith at the same time, implementing all their features. You're going to be shipping stuff more likely than not on a schedule of every few weeks, you know, on a good day. Whereas microservice architecture, a developer who is hired into one of these organizations can ship a feature his or her first day on the job in a couple hours. That's amazing. Now, that's the hope of microservices. And I would say microservices actually do deliver on that promise, but not without a few caveats. I love this slide. This is made by Daniel Wood. He gave a talk on microservices, and it represents, I think, the experience that some people have had when they try to build their first microservice application. It just ends up with everything being a gigantic mess. It's super complicated, and as a result, some developers are pushing back against microservice-based architectures because of the overhead, the complexity, the feeling that couldn't things be simpler? Why do we need all these microservices? Why can't we just go with the simpler monolith? And honestly, I'm sympathetic to that. But at the same time, we need to acknowledge that the pains solved by the microservice architecture, they are very real. And also the problems or the complexity, the challenges of implementing the microservice architecture are real as well. So there are good things as well as potential drawbacks. Let's take a look at some of the drawbacks. One of the challenges in microservice-based architectures is discovery. Discovery happens when subscription service, for example, requires the transactional email service. How does it know where to find that transactional email service? Well, that process is called discovery. And that's one of the challenges that we need to solve. In addition, we have the challenge of security. So back when our application was deployed as a monolith, basically the entire application is running inside a trusted environment. All parts of the code trust all other parts of the code. Your function A that's calling a function B can trust it. Whereas in a microservice-based architecture, the transactional email service is somewhere else. How do we know that's the real transactional email service and not a fake? How do we know for sure? We've got to do security. And by security, I don't just mean SSL. We can't just encrypt things. We've got to actually make sure that transactional email service is the one that we wrote and not someone else's one. In order to do that, there's lots of different authentication mechanisms that you can use, but you have to think about that. And there has to be some brain space and some code space and ops space devoted to solving that particular problem. In addition, we need monitoring, and we need monitoring more than ever for a microservice-based architecture, because microservice-based architectures have more moving pieces, way more moving pieces. Thousands of microservices, tens of thousands of microservices at a large company. And as a result, we need detailed metrics on how these things are functioning. So we have the ability to, when ops is deploying them and monitoring and managing them, they can see what's going on and they can identify problems and respond to those problems. And that requires super detailed metrics, and not only metrics, but logging, and not just logging, but a more advanced type of logging known as distributed tracing. Because basically in the monolith, our application functions as a whole, whereas in the microservice, it's fractured. And so to satisfy a single request for a little bit of functionality, a request comes in from the outside world, from the user or something, it's going to end up pinging through dozens or hundreds of different microservices. And we've got to keep track of all that information in order to do a good job helping us diagnose problems after the fact. And that whole distributed tracing, that adds a certain amount of complexity. We also got to think about recovery. So what happens in a failure scenario? Catalog goes down. How do we restore that service? And not just how do we restore that, but what if catalog is depending on the user account service? We've got to think about user account service goes down. What happens to catalog? We've got to think about failure recovery. We've got to think about being resilient in the face of transient errors when the downstream dependencies that we have are malfunctioning for short periods of time. Routing is another concern. So when we get a request and that request is designed to go to the fraud service, there will be, in general, lots of different nodes running the fraud service. How do we decide which request gets which node? It gets executed by which node? And that's the routing problem. And the routing problem, routers can be used to do lots of different things, but one of the things they can be used to do is versioning. So we can have fraud 1.0 running concurrently with fraud 1.1. And that's very common in advanced microservice architectures. We also have to think carefully about deployment. And that's because in the monolith, we have our giant monolith that we ship out. We package it in a container and we deploy it. And we scale that, and that's all very straightforward. But deployment is much more complicated in a microservice-based architecture, because any given microservice is deployed on a variable number of nodes. They're all sort of independent. They're not necessarily connected. Some microservices might only be deployed on 2 nodes. Others might be deployed on 10,000 nodes. It depends on the needs of those. And also we have versioning to think about. So we may have concurrently, we may have subscriptions 1.0 living alongside subscriptions 1.1. That's something that could happen. Load balancing is another consideration. So if a request comes into fraud, we've got to make sure we don't overload any given node with the fraud service. We've got to make sure we balance that across different fraud nodes and make sure that the overall traffic remains fairly constant if you look at that on a per node basis. And then finally, we've got to worry at least a little bit about traffic control. So sometimes we don't actually want to impose certain limits or other types of policies on certain services to avoid problems like a new user account registration service. We may want to do some traffic control or enforce other policies associated with that. And that's additional work and complexity that we have to worry about with a microservice-based architecture. That's a lot of different stuff. It is a lot of different concerns that you have to worry about when you're trying to do a best practice microservice-based architecture. And the reality is that Yeah, some people have had bad experience with microservices. I can totally see if you throw a new microservice project at a team that's never done it before, honestly, there's just a lot of learning involved, and it can take a lot of experimentation with different technologies and tools and trying to understand exactly everything that goes into creating one of these killer microservice architectures that have been attracting companies to that style of developing applications. If you want the same benefits as a big company who is successfully using one of these next-gen microservice-based architectures, you need to pay attention to detail, and you need technical expertise. A lot of things can go wrong. And if you do have that technical expertise, if you do pay attention to the details, then you can reap the same benefits as the big companies that have been successfully using these architectures. I don't even think there is a big tech company that does not use microservice-based architectures, which just shows you how successful it's been. And I think you heard earlier in the day from Fugo that it can even make sense for startups, basically. There's no reason that you have to be in Amazon before you turn to a microservice architecture, because the tooling out there is becoming so good that the cost of deploying best practice microservice architectures has gone down. All right, so in the face of these challenges, where are things going in the future? And I'm going to rush through this final section. Okay, I have 10 minutes. Fantastic. Okay, so I'm not too far behind. Kubernetes is a fairly new technology that has become almost an operating system for deploying and running today's cloud-native applications. And even though Kubernetes is not designed specifically for microservices, it is nonetheless an extraordinarily good fit for deploying microservice-based applications. And it provides a lot of the infrastructure required to deploy and operate, manage, and monitor microservice-based applications. And the fact that it's become so successful and so synonymous with cloud-native applications is a real boom, because it means that there's a whole developing ecosystem that is tailored to adding. Kubernetes does not have everything you need if you want to deploy microservice-based architecture, but it has a lot. And the fact that it's become the sort of de facto standard for deploying cloud-native applications has encouraged a lot of open source projects and frameworks and vendors to produce Kubernetes compatible tooling. And it's also led to evolution of the Kubernetes platform, because now it has features in there that is designed basically hook points for you to add other types of functionality that microservice architecture needs. And so I would say that Kubernetes is definitely a key part of any current or future microservice-based architecture. You need to be running Kubernetes. You need people with Kubernetes expertise. You need training around that and so forth. Kubernetes has architecture similar to the one shown here. It basically controls all these different kubelets. They're called. It has a proxy for each one. It has a scheduler. It has all the different pieces to monitor and deploy this. It can grow and scale. It can do restarts. It can assist with security concerns to make sure that things are relatively secure. It even has a bit of functionality in there to help with discovery, depending on how you choose to solve that problem. So you can solve lots of parts of the microservice problem by using Kubernetes. Kubernetes does not solve everything, however. It doesn't have deep insight into what a microservice is. Kubernetes is much more general than that. And so to assist with some of the other concerns that I mentioned, a lot of people have turned to so-called service meshes. And the top 3 service meshes out there that assist with building and deploying a microservice-based architecture on Kubernetes are Consul, Linkerd, and Istio. And these 3 solutions, they all have an architecture similar to the one you see here, where when you deploy a microservice, you actually deploy it together with a sidecar proxy. It's called a sidecar. What it is a proxy. And these sidecars, what they do is they act as a little envelope that totally encloses the microservice. And all communication into or out of the microservice, it goes through the proxy. And as a result, the sidecar, it has full insight into everything that the microservice is doing. And And that helps solve a whole host of problems. For example, that solves monitoring and distributed tracing and other types of concerns because they know the traffic in and out. So they can actually provide for free a lot of the features that you would otherwise need to bake into your microservice. They can assist with recovery. They can perform routing. You in a service mesh, you have not only all of the different sidecars that are attached to all your microservices, but then you have orchestrators and monitors and supervisors that sit at a higher level and keep an eye on stuff and make sure it's doing what it's supposed to be doing and handle concerns like load balancing and traffic control and enforcing of different policies and helping microservices discover each other and doing security and so forth. The quality of these technologies is becoming very high. It's becoming easier and easier to get all of these features that I mentioned earlier in a cost-effective manner by using one of these Kubernetes-friendly service meshes. Another very interesting area that I think is going to affect the whole microservice framework is this idea that even though service meshes are extraordinarily useful, you can see Kubernetes, it keeps on expanding the types of functionality it's offering. It's almost eating into service mesh territory, really. Like Kubernetes keeps on absorbing some of these features at the fringe of the service meshes. And then in addition, frameworks like Spring Boot, for example, keep on, have that long history, but also they keep on adding features to make it easier to ship best practice microservices. So I honestly think that there's a chance, a non-zero chance, that at some point the service meshes might fade away into the background and become more niche. I think at some point we might only be using smart next-gen microservice frameworks that bundle all of these rich features together and that deploy natively into Kubernetes and take advantage of all the features that it continues to add to make it more friendly for microservice deployment. So I think that's a really interesting possibility to pay attention to. And then in addition, we have a whole host of next-generation so-called stateful functions or stateful serverless or stateful workflow solutions that are designed to shift the way you think about building distributed applications. And these technologies are none of them are strictly focused on microservices per se, but the fact is this class of technologies, what it's trying to do is enable ordinary developers to write business logic and not have to pay attention to infrastructure, not have to pay attention to databases, okay? Don't even consider the databases exist. Don't consider that there are such a thing as microservices, version microservice. Forget as many details about infrastructure as you possibly can and focus only on business logic. And they're trying to do that in a variety of different ways, but ultimately all of them are trying to create this concept of a computer, basically, that basically program as if you were working on a computer that never goes down and that just runs forever, and in which all the data that you touch is persistent. So you update a variable and that just is persistent. It can survive forever. That's a new way of thinking about computing. And it is highly likely, in my opinion, that this class of solution ends up altering the way we build and deploy microservice-based architectures. It could radically simplify it. It can simplify it because when you offer a programmer a constrained environment in which they don't have to worry about infrastructure, then you can provide a lot of the stuff that I mentioned before, like security and provisioning and deployment and monitor, all that stuff you can provide for free because your constraints liberate and liberties constrain, as the saying goes. You give the user a small bit of functionality and then you can provide a very solid foundation that enables them to forget about the infrastructure, and you handle that with the platform itself. So this is a space to keep an eye on. I do think that it will end up changing the way a lot of companies, especially the non-tech giants, end up shipping microservice-based architectures. And then finally, I should mention that all of these challenges, they do have solutions, and they have open source solutions in many cases. And actually, for every one of these different challenge areas for microservice-based architectures, there probably exists 2 to 20 different open source solutions you can use to solve them. And there's no substitute for training. So equipping your developers with training, whether that's books or workshops or whatever. Also, senior expertise, making sure that your teams have someone on them, ideally a few people, who have built and deployed successfully a best practice microservice architecture can go a long way to ensuring project success. And then finally, there's plenty of consultancies out there. My friends at Scala C, for example, and my own company, Ziverge, who you can pull in to help oversee a project or provide some extra help in order to ensure a successful execution of a microservice-based architecture. So, in summary, although the microservice-based architectures are complex to do right, new technologies like Kubernetes and service meshes, maybe even smart microservice frameworks, are helping to democratize microservice technology. And all that said, there's no substitute, at least at the current moment in time, for expertise. So training your people and making sure you have people who've done it before on the team working with you is the key to having a really good outcome for one of these next-gen microservice-based architectures. And with that, if we have any time, actually, I think I used up all my time, but I'm happy to say this was not 2 hours.
Thank you very much, John. That was a great presentation. And we have a couple of questions and have 4 minutes to the next speaker, but I will try to pick maybe one or two. So the first question, hi, John, could you explain how Zio Web, which I think is Zio Microservices now, will help us to solve the problems of microservices-based architecture?
Yeah, that's a great question. And I think my vision for Zio Microservice is to basically become that smart microservice framework that you use to deploy microservices into Kubernetes-based architecture. That it would bundle together a solution to all of the different concerns that you have when you're building and deploying microservice-based architectures, taking advantage of all the features in Kubernetes. Basically, I would envision Zio Microservice to be an alternative to a traditional microservice-based library or HTTP library or gRPC library and a service mesh. So if you take basically the best parts of a service mesh and the best parts of an ordinary gRPC or HTTP library, bundle them together into something that's type-safe, composable, very user-friendly, enables you to be very productive, fits well into the Zio ecosystem, and runs natively in Kubernetes, that would be my vision for Zio Microservices.
Okay, thank you. And maybe another one, like a comment or the question, I feel like we end up creating microservices that only ever do one thing, and it feels like too much overhead. How can one determine the correct level of responsibilities when drawing boundaries?
That's a great question. I think there's two answers. The first one is the overhead for creating and deploying microservices is too high. It's way too high. You should be able to create and deploy a new microservice in 30 minutes. Honestly, I believe that should be possible. It's not possible right now, but hopefully as we invest more into this space, it will become possible. And then the other thing is the correct level. I think you need to look at basically, when you're packaging up everything that goes into a microservice, you need to look at functionality that's related as well as that has similar dependencies. So if you have a bunch of functionality that all needs to talk to Postgres and use the user accounts table as well as these other 3 different functionality, that's a sign all of those need to be packaged together. I think it's always a hard question. I don't think that there is a scientific answer, but I think looking at the dependencies, looking at how related they are in terms of functionality, and looking at how often is it that changing one would lead to possibly changing other parts inside the same module can all help you draw that division between microservices such that you don't have to pay too much. You shouldn't be deploying, it's too costly to deploy individual routines as microservices.
Okay, so we have space for one more question. I think that even paying attention to detail, something can go wrong. There are architectural smells that could indicate that my microservices are starting to break down. Could you refer to that, John?
Okay, architectural anti-patterns for microservice-based architectures. Well, I would say if you're following all the best practices, you're in a reasonably good place. But like you point out, that doesn't guarantee that everything's going to go well. So, for example, one of the concerns you have to look at is, do you have continuous deployment set up? Are you able to literally deploy a new are you doing canary-based deployment? Okay, so do you have some protection? When you roll out a new service, do you have a way to evaluate whether or not that's functioning properly? And if you don't, there's something wrong with your architecture. You don't have the mechanism, the machinery necessary to figure out if things are going wrong. Also, can you do instantaneous rollbacks? If 1.1 is leading to problems in production, can you instantaneously, in your canary-based deployment system, can you roll back to 1.1? Yeah, or 1.0. If you can't, there's a problem. I think the other question about how fine-grained or coarse-grained your microservices are is a good one. So even if you follow all best practices, you can have really an architectural anti-pattern by deploying lots of too fine-grained microservices. You know, if you're shipping individual functions as microservices, you're setting yourself up for way more overhead and cost than you ideally would be setting up yourself up for, and you can do that while still following all of the best. So having the right level of the right number of individual routines inside of a microservice that all relate to some core area of functionality is critical. I think some of the work that people have done, like Bob Martin and so forth, the Agile folks, basically, in elucidating the principles of good object-oriented design, there's a lot of useful there's a lot of literature that you can pull into the design of a successful microservice architecture on what's the right level of functionality that every one of these units should ship with.
Okay, yeah, there are a lot of questions from our audience. So maybe just the last one. What is the best approach to implement microservices, Kafka or Akka with ZIO technology?
Yeah, that's a good question. So obviously I would use ZIO no matter what. As for Kafka versus Akka, I think Kafka has opened up the door to implementing microservices in a different way, stateful microservices in a different way, because you can use the Kafka log basically combined with event sourcing or some other similar pattern like that to really do a lot of the things that formerly you would have had to use Akka cluster in order to do. But I think that ultimately the key there is going to come down to latency. If you have super low latency requirements, then that's going to probably shift you more into the world of using Akka. So building something on top of Akka cluster, and there's a ZIO library that can help you do that. If you have maybe higher latency requirements, or maybe you're more in the realm of like data processing, ETL, something like that, that's probably going to push you more into the Kafka. Ultimately, I think it's going to come down on the details of your business requirements, which of those two different technologies you choose.
Okay, thank you very much once more, John, for joining us. It was always a pleasure to have you.
Thank you for having me.
Thank you very much.